Now let's look at another important system register for exception handling. The register is the ESREL1 register. So let's analyze ARM reference manual that define the ESREL1 register. ESREL1 register means exception syndrome register. So this register is hold the different information in each the bit field. Among these bit field, the most important bit field is EC bit field. This bit field locates 26 to 31 bit position. In this bit field, 26 to 31 bit field, it has the exception class information. What is the exception class? So exception class is the bit encoding value that represent the cause of exception. So software usually read the value of the exception syndrome register to identify the cause of exception. So ARM architecture define the many of the exception class information. For more information, we can read the material of the ARM reference manual. Now that you get to know the ESREL1 register, let's look at the assembly instruction that is read the value of the exception syndrome register. So if you run this assembly instruction, the value of the exception syndrome EL1 register is written to the X1 register. Please take a look at this. X1 register is one of the general purpose register in the Armv8-A architecture. So if you use this instruction, the value of any of the system register will be written to the general purpose register. Just like another system register, just like ELREL1 register and FAREL1 register. So ARM core update the ESREL1 register when the generating exception. So let's look at this diagram when ESREL1 register is updated. Just like another system register like ELREL1 register or FAREL1 register, the exception syndrome register is updated when the ARM core generating exception. Right after the parent counters move to exception handler, software read the value of the exception syndrome register, ESREL1 register, to determine the cause of exception. So when the exception occurs at exception level 0 by running as VC assembly instruction, in this case, so ESREL1 register has the exception class. Please note that exception class is updated in the 26 to the 31 bit position, as you can see in the register layout. What if the exception happen in Linux kernel by running the memory access assembly instruction? In this case, memory overload may happen. But in this case, the exception class will be updated to the 26 to 31 bit position inside exception syndrome register. In this case, the different exception class will be updated to ESREL1 register. The exception class value can be defined in the ARM reference manual. So if you want to check out more information, then please refer to ARM reference manual. And another important thing you have to understand is that when the exception is taken to exception level 1, this register, ESREL1 register, is updated. When the exception is handled at exception level 2, in this case, ESREL2 register is updated instead of the ESREL1 register. So that is another important thing to remember. Now that we walk through the important system register from VBAR-EL1, ELR-EL1, FAR-EL1, and ESREL1 register, in the next lecture, we will explore the system register that is related to virtual address configuration.